Hello students, let us discuss about resolution of forces. What is resolution of forces? So resolution of forces is nothing but the replacement of a single force by several components which are which will be equivalent in action to the given force. So basically the case in which a single force is to be replaced by two components in the engineering mechanics, it's very convenient and which are mostly commonly encountered. By using the parallelogram law, we can resolve a given force R into any two components which are P and Q intersecting at a point on its line of action. So we can use the parallelogram where actually the angle whatever is given, so mutually P and Q. So this is the reverse of a parallelogram law. Now we will take an example. Let us R is the resultant force R in parallelogram law, or in this case any force R, which can be resolved into two other components or many several components. In this case, let it F1 and F2, which are mutually having an angle to each other. So actually in this case the R is resolved into two components, F1 and F2, which are at any direction, at any particular magnitude, so that their resultant, that means resultant of F1 and F2 must be R. So they are mutually equivalent to each other. Now to simplify it for our solving the problems in engineering mechanics, what we will do, instead of taking any arbitrary angles F1 between F1 and F2, we will have a certain known angle which is mutually perpendicular. So let us say R is the force which is to be resolved into two components, that is Fx, which is along x-axis, and Fy, which is along y-axis, for our convenience in coordinate system. So either it can be having 90 degree to each other mostly. So in this case actually Fx and Fy are mutually perpendicular to each other and their resultant will be R. So in this case actually to find out R and or to convert from R to Fx or Fy is very easy. That's why mostly we use this coordinate system or this resolution system into two components, that is Fx and Fy. Or in other words, you can say R can be resolved into F1 force and F2 force, which are mutually perpendicular to each other for our convenience. Next, we will have an example of different forces in a coordinate system and to find out their force in the method of resolution. So let us have the coordinate system x and y axis, where actually there are four quarters, starting from the first quarter and going to the second, third, fourth in reverse order. That means the anti-clockwise direction. So then this means first one will be positive, x and y will be positive. Second one will be x will be negative and y will be positive, and third will be x will be negative. Sorry, x will be negative and y will be positive. And in this case, fourth one, x and will be positive and y will be negative. So basically, positive positive, then negative x, positive y, then negative x, negative y, then positive x, negative y. So in this case actually, if you see in the coordinate system, let us consider different forces. Starting from one force, let it F1 in the first quarter. So that means Fx and Fy, we can resolve it into two forces. Similarly, it's having a magnitude of F1 and direction of theta 1 from the x-axis. Similarly, let us another force F2, that is having an angle theta 2 with x-axis in the reverse direction. So the angle can be taken from x-axis from the first quarter also, in anti-clockwise direction, but it's convenient to take from the axis nearby that one. Then the third force let it be F3, which is having an angle of theta 3 from the x-axis in negative direction, and another force let it F4 is here, which is having theta 4 is the angle from the positive x-axis. So now these are the four forces. What we have to do is you have to resolve it into different components of fx and fy, and you have to add them together to find out the resultant. So what we have to do is, so in the case first, all the forces you have to resolve in x direction and y direction. And similarly this one F2 in x direction and y direction, F3 in x direction and y direction, by taking the theta as sin theta and cos theta, sine and cosine of the forces. So similarly F4 can be taken this way and this way, so the direction should be either plus or negative, plus or minus according to the quarter they are there. So fx, for example, second quarter f2. So f2 in y direction that will be positive, and fx will be negative. So in this case, so what you have to do, so to sum it up in x direction and y direction, and finally what we will get, fx, summation of fx, that is rx. You have to sum it up with all the proper signs, that is rx, the resultant of all the forces in x direction, that is rx, that is from the coordinate system, and let's have ry, which is summation of all the forces in y direction. So that means with all the signs from these four forces, if it should be added up, then you can find out rx and ry. Only two components will be there finally. Finally two components will be there, so that it is very easy to find out the resultant. So the resultant can be find out in different methods, where actually rx and ry is already known, and the angle between rx and ry is 90 degree. So it's very easy to find out by using any method, either by parallelogram law methods or maybe law of triangle method. Already we have explained how to find out this law of triangle. We will do it again in the next. Okay. So let us see. So this is a very simple method where actually you can, if there are number of forces are there, you can easily resolve into two, rx and ry, and you can find out the resultant. So and the resultant will be having some magnitude and also direction has to be there. So that is theta x is the with the x-axis, and theta y you can get the other one, which is 90 degree minus theta x. So these are the projections of R sequence rx and ry. So next is the analytical method of parallelogram law. Basically, let us have the parallelogram forces. Let us E is the force, one force of the parallelogram law E, and another force is Q. Okay, and they are meeting at point A. So P and Q are the two forces in the parallelogram law. Now what we will do, we will have the angle is in between them is alpha, let it be, because it is all the forces is to be magnitude and direction should be there. So two forces are there. Now let us draw the parallelogram. So let us, this is the parallelogram A, B, C, D is the parallelogram of P and Q force. Then the resultant will be the diagonal of this one, A, B. That is the resultant of that one, R. Now let us have the angle between P and the resultant. Resultant force R is, let it beta. And similarly the angle between Q and R is gamma. Now what we will do, the resultant of two forces E and Q will be equivalent to square root of P square plus Q square plus 2PQ cos alpha. Alpha is the angle between force P and Q. So this is the formula for the resultant force of parallelogram method. Now we will convert it into the law of triangle. Let us draw the triangle. So first you have to draw the force P, let it be, if the direction is there A, B, let it be A, B is the force P. Okay. So this is the P force. Now next to the one by another. So next the force Q should be start from the point B. Let us start from B. Okay. So from B to C, that is related Q is the force which is having an angle of alpha with the Q is the angle of alpha with Q. So let us this line. So this is the angle of alpha. Then what you will get, the resultant is just joining A and C, then you will get the triangle. So the parallelogram has to be converted into a triangle. So where actually the triangle, this one is P, one side is P and Q is other force, the other side one after another, and when you join them together or close them, then the resultant will be there. So this is the resultant. Now the angles. So alpha is the angle Z1. So the inside the triangle, the angle will be first angle between P and Q will be pi, that is 180 degree minus alpha. So this is the angle between P and Q inside the triangle. And another other angle between P and R is already in the parallelogram. So that is P and R is beta. And similarly, the angle between R resultant and Q force is gamma. So this is the triangle. So now if you see this triangle by the triangle method, now what we will have a relationship between beta and alpha. So now we have to find out either beta or gamma. We need the resultant which is having some angle with P or Q. So how we find out? Let us have one line of projection from C to AB line. So this is perpendicular line. Okay. So now if you see this, let us have sin beta will be equal to Q by R sin alpha. How? Because if you see, let this is that point B, then you see ACD triangle. Okay. ACD triangle, we will say right angle triangle, R sin beta is this much, CD. Okay. And if you see the triangle CBD, alpha angle is this one. So that means if you see Q sin alpha will be equal to CD. So that means if you equate this same one, the CD is the common of these two triangles, there is ACD and BCD, then you can find out the sin beta is equal to Q by R sin alpha. This is basically if you just equate the two triangles, from there you can find out easily. Similarly, now the other one, let us extend this line CB and join perpendicular line from A, that is A. Then you can find out that sin gamma. If you see again two triangles, that is AEC is a right angle triangle and also AEB, both are right angle triangle and common is AE. So now if you see this angle, because this total angle is 180 degree, pi minus alpha, this one is alpha. So if you say sin alpha is equal to AE, and not sin alpha, there is P sin alpha. P sin alpha is AE. Similarly, if you see AEC triangle, R sin gamma is AE. So if you equate each other, then you can find out sin gamma is equal to P by R sin alpha. So anyway, it's very easy to find out sin beta is equal to Q by R sin alpha and sin gamma is P by R sin alpha. So this is the analytics of parallelogram and um, law of triangle. Okay. So now what we will do? So let us have two forces P and Q, and their angle between the P and Q is 0 degree. In this case, the resultant will be equal to P plus Q. If you see P and Q are there two triangle forces, then the resultant will be P plus Q in the same direction, because there no angle is 0, so that means the um, resultant will be the addition of both forces in same direction. Similarly, if you say that angle between the two forces P and Q is 180 degree, that means they are opposite and collinear forces. So the collinear forces and but often opposite to each other. So in this case, the resultant will be P minus Q. P is greater than Q, then it will be P minus Q. So this let us P is the bigger one and Q is that side. So if you say then the subtraction from P to Q, the resultant will be R. Okay. So also you can put into the that equation, that is R is equal to square root of P square plus Q square plus 2PQ cos theta cos alpha, where alpha is 0, then cos alpha will be uh, 1, so that R square will be equal to P plus Q whole square root, or you can say R will be equal to P plus Q. Similarly, alpha is 180 degrees. In this case also, that will be minus cos alpha will be minus 1, so that R will be P minus. Also, when alpha is 90 degree, or that means the forces are mutually perpendicular to each other, P and Q, then the resultant force will be P square plus Q square plus 2PQ cos 90 degree. So let us have two forces P and Q that are mutually perpendicular to each other, that means 90 degree is the angle between them. Then the resultant will be equal to square root of P square plus Q square. In this case, because 90 degree cos 90 degree is 0, so this will be cancelled. So R will be equal to P square plus Q square square root. In this case, the resultant force R is having some angle with either P or Q in this case. So to find out that, so you can easily let it beta is the angle between the resultant force R and P force. Then you can say tan beta is equal to Q by P, and you can easily find out from there. If you know the Q and P, you can find out the direction of resultant force. Next is the free body diagram. What is free body? Free body is nothing but it's a body which is not connected with other bodies and which from any given position can be displaced in any can be displaced in any direction in space. Then what is free body diagram? Free body diagram is a sketch of a body which shows the external forces and the reactions exerted on it on the removed elements. So in this case, we will have some examples. Basically, a free body is a body which is not connected with other bodies and which from any given position can be displaced in any direction in space. That means we can easily have any external force, then it will be displaced from its original position. And free body diagram, then is in any complex conditions in the case during the solving of the mechanics, it's very convenient method to displace to detach all the other components from a particular point of interest, so that it can be taken as a free body. Then it's the resolution all the forces at this body can be easily done with sketch. So that is called the free body diagram. Let us see what free body diagram. So let us have a simple problem, a simple example this is a ball which is resting on the surface or floor. So that means the ball has some weight. Let it. So the ball has a weight, and according to the Newton's third law, every action has a reaction which is equal and opposite to the direction of force. So let us have, because the point of contact, let it A. Okay. So now what we will see. So we will just because two bodies are in contact to each other. Now what we will do? We will free them. So that means if you free them, the ball will be just free from the floor. But the forces has to be there to be it in equilibrium, because the ball cannot be stay in the space. So it has to be some force so that it can be balanced. So as you know, the ball has a certain weight. That is, W is the weight of the ball, and this is the imaginary line where it contacts with the floor. Then you have to find out the opposite and same reaction force, that is, let it RA, because it's a reaction force at A, point A. So this is having the force RA which is in opposite direction. Now we can see this ball is now this case is a free body diagram of the actual condition. Okay, so where actually this is in equilibrium, where the two forces are opposite to each other. Now we will have another example. That is another block of weight W is resting on the floor again at A. Now same way we can have two body diagram here actually. Basically all the points we have to show in the three body diagram, so that we can go further for complex problem solution. Okay, so now let us say the free body diagram. This one, first one is the block. So block is having two forces, one is the downward force and one is the reaction force. So downward force is the weight of the this block, and upward force is the reaction force from the floor, that is RA. Okay. So now coming to the floor has only one force, because floor is not giving any, it is not giving force unless otherwise there is force from the block. So it is only giving the opposite force. So in this case, so the force is on the floor, that is only downward force, that is RA. So this is the free body diagram, two free body diagram of the one block and floor contact. Next we will go another example of an inclined plane. That is, this is the inclined plane. Okay, and its inclined angle is, let it alpha. On the inclined plane there is a ruler. Okay, so let us, one ruler is having resting at this point. So the ruler has a center point O, and on the handle of the ruler, so a force P is applied. Let us, P is applied on the force. So this is just resting in this way. It is seen very complicated, but it's not very complicated. It's very simple. If you draw the free body diagram, let's have a force of also the handle where the force is applied P, which is inclined angle of, let it another angle, that is theta, with the horizontal line. So the surface is alpha degree inclined to the horizontal, and the handle with the force is application of force. We can make it the direction of the force P is at the theta angle from the horizontal. So, and let's another force W, weight of the ruler is W. So now all the forces, and the contact point is A. So now everything is known how to proceed to find out different forces on the ruler or on the floor. Now we have the free body diagram. So let us, for free body diagram we do not have all other things, only the ruler and the handle line. So ruler is having the contact line of the surface, that is, this is the imaginary line of the surface, what you have to draw only, and which is having a angle into the vertical line, that is vertical line and this line, what will be the angle? So we will having another horizontal line also you have to draw. Then the force of application, the magnitude of the force, let it P, which is along the handle line. You have to show. This is very simple. So then the angle is theta, and if you say the weight of the ruler, that is W. Okay, so that is coming towards the downward. This is W. Then if you see the reaction force will come from the surface, there is inclined surface, that is RA, because it's exerting at point A, so this is RA. And if you see the angle between the RA and the vertical line is alpha. If you see that alpha is the angle from where it's given in the inclined plane, so it will be alpha. Now the the center point of the ruler is related to O. Then if you join the O and point A, just these are the imaginary lines. Then this is done the P body diagram. Now all the forces are done. P, W and RA. Three forces are there on the ruler. So now you can easily calculate, because all the everything is, this is just a like geometric body, and you can easily calculate all the forces by geometrical method and resolution of forces. By already we used the resolution of forces, but in this case P will be P sin theta and P cosine theta in this direction, and W will be the downward, and RA can be resolved into two components. Then you can balance each other, then you can solve it. We will do different problems later on. So next is the another example. So let us have two pivot points A and C, from where two cables are connected together, and so that means one electric bulb is hanging here. Let it, the weight of the electric bulb is W, or any mass is hanging. So through two roofs which are crossed each other, A and C are at different level of pivot points. So let us, one is the roofs of 1, 2, and another is their points are there. So let us, they are meeting at point B, and D point the weight is hanged. Now if you see the another roof or cable is 3. So there are 3 cables, 1, 2 and 3. So they are like cross each other. So they are tied together, and OW is the weight. Now what you need to know, you need to know the dimension of geometrical dimension, so that the angles can be find out. So now let us draw the imaginary line. This is the imaginary line, or a horizontal line, and the alpha is the angle between the horizontal line and the roof cable 1, and similarly that is another angle, this is beta, which is the angle between the cable 2 and the horizontal line. So this is the actual case of this system. So this is the weight and cable system. Okay, now what we will do, we will draw the free body diagram. So here actually it also looks little complicated, but you can make it very easy. First, what you have to do, you have to divide it into more than 2 components or points, so that you can draw the free body diagram. First of all, there are 3 things. One is the weight. So first let us think about weight and imagine that others are not there. So if weight is there, only weight is hanging, so then what will be the free body diagram? So let us draw the free body diagram of only weight. So only weight is the block, or you can say anything you can make here. So then here what are the forces? One force is the weight of the that block, that is W. So that will be acting downward. Okay, since this weight is in equilibrium, so there should be some upward force to make it in equilibrium. As already you know, so any body which is in equilibrium, there is no resultant force. That means that W force downward should be some similar force should be in upward. So that means if you see there is a cable here, there is cable 3 from D to B. So now you see there is another force which is upward, that should be equivalent opposite. Or let us, now we are not calculating, just we are imagining whatever. Okay, so there is here no other points are there, or no, it is not tilted, it is straightforward. So there will be SD. So why SD? Because S is the tension or whatever you are seeing here. There is a force, we are just giving a prefix of D for point D, because it is tied to point D. So the weight is tied to point D, so that's why the force is SD. Now in this case, if you see SD and W are opposite and equal to each other. So this is the free body diagram for the weight. Next free body diagram should be the cable, because if you see D and B, cable 3. Now we see cable 3. This will be like very simple point. So here actually the cable will be having two forces. At one force is SD already we calculated. So this is at the point D. So the force will be SD. That is downward, and one force will be, because it's the cable is also in equilibrium. So if you see at the point B, so then there will be force SB. So that means that will be upward. So for the cable S3 is having two forces, one is downward and one is upward. It is SB and SD. So this is the free body diagram of the cable. Next, what is the point? Next one is the third point. The important one is the B. Let us take the B point. So this is the point B, and there are three components are there, three ropes are there, or three cables are there. That is this S2 is the force in the cable 2, and S1 is the force in the cable 1, and another cable is there, that is downward, that is S3 let it, or in this case because it's starting from B, so you can save it SB or S3, same one. So since SB and SD are same, that is in the S3, you can take it. So we will have this actually more calculation later on. Now it's only how to draw the free body diagram. So this is the free body diagram of the third point, the most important point. So actually now what you have to draw the imaginary line also, the horizontal line. Let's draw the horizontal line, and you give the angles alpha and beta together, and this is done. So now you can see, so this is the free body diagram of three free body diagram for the whole system of this rope and the weight hanging system. Okay, so we can have more examples in the other classes, so where actually we will solve a lot of problems.